We'll look at the chart work question in the December paper. The vessel has gone to shelter in the bay given, and we observe the light float and the cross Vinogi point, the two bearings given, plus the head here. The eastern extremity was 6.1 miles, and we have to find our position. So the two here, what you do of course is get the difference between them, which happens to be 90 degrees, subtract from 90, 0. So you would join the two together, find the midpoint and draw a semicircle. Now obviously the semicircle is going to be on this side because we're told this is the bay that we're going to drop anchor. Once you've drawn that semicircle, I've put dotted lines there. That's the only reason I've done that, is to try and make it stand out. Then the eastern extremity, go across at the distance given, and where it cuts our semicircle, that's our fix. And I'll just put here what I got there. The bearings 188 and 088 true, so I got a compass error of 3 east. There's my position, and the deviation will be 7 degrees east. So that's the first part, position of the vessel and the deviation. Then the vessel is going to leave at 0700 hours, and we're going to get 5 miles, and it is, you can't actually see it on here, but I've plotted 5 miles due south of Capel Island. It's 1100 hours. We've got a northerly gale and a tidal stream, and we need our compass course and the position when the vessel mine headlight is abeam to starboard. Now there's two ways you can do this. Plot the course you have to make good all the way from your fix to the waypoint. You've got 4 hours to do it in, so you could actually measure this line, split it into 4 1-hour sections, and then do the tide for 1 hour, and then that would give you your vessel speed and the true course that you have to steer. Myself personally, I complete the whole triangle, so I've plotted 4 hours worth of tidal stream here, run my water track with the 1 arrow, and then I measure from the end of the tide to the waypoint, and that will give me the distance that we will actually to work out our speed, because of course the tide is pushing us along. So from that I got the course to steer, the water track if you like, 246. Leeway is 4 degrees northerly, so the actual helm will be steering 250. Then we apply variation, deviation, compass course to steer, just my own workings, 259. Divide that distance by 4 hours, and I got a speed of 10.7 knots because it was 42.8 miles by my working out. The beam bearing, remember, it's a beam to the ship's head, so it isn't a beam to this water track here. Had there been no leeway, yes, it would be a beam to this one here, but we have got leeway, so we have to apply that because the helm is actually steering 250. And the position where mine head is a beam, I've marked it off, and that was the position I got there. So that's just my own workings, but I thought quite a straightforward question. Working out course to steer and speed. The only perhaps observation I would make, I do think they make these a little unclear when they say the steaming speed required. Now do they mean the engine speed? You see, I always take that to mean, well, what are you going to ask the engineers to set your speed at? So I'm saying, well, if we set the engineers to speed up for a speed at 10.7 knots, we will reach that position at 1100 hours, providing the tidal stream is correct. I think if you're unsure in an exam, put them both down. Put the ship's speed down and the speed that you would actually make good over the 4 hours. Obviously the speed you'll make good will be more because you've been helped by the tidal stream. So there always is a little bit of confusion with that. But my advice would be, any doubt, write them both down so that you let the examiner know you quite understand the difference between the two.